Hello, welcome to this new tutorial on Java. So today I'm going to start a new series on data structures. So basically, we have done a lot of videos on the data structure already, but those were related to how to use the existing data structures or the implementations which were already provided as part of the libraries. And this data structure series I'm going to focus now is how to implement those data structures yourself. Actually, let's say somebody asks you how to implement a linked list in Java, and then you have to do your own implementation on the linked list. Actually, so I'm just going to focus on this implementation part uh, in these videos. And these kind of questions are also asked in the interviews, where you might be asked to implement a linked list or implement a queue or a stack, those kind of stuff. Actually, so let's see, I'm going to go to this example first. So before you look at the pictures, so just want to understand what are the data structures. So this is just general topic. It's not related to Java. The data structures are it's a computer science topic, and it's used in different languages. So it's really not depend on the language. So these are just concepts you have to master, actually. So or you need to know these concepts. So data structure, if you want to say, this is really a way to organize the data, actually, or you want to keep the related data together so that it's easy to process the data. And what kind of data structure you want to use, that depends what kind of data format you have, so that will dictate the data structure to use. So in simple example, let's say you want to store numbers 1 2 3 4 5, and we know that you can store those in int in Java, actually. So int is really a data structure to hold that value. Or if you want to store float, there's a float kind of data. You already have this data structure for float in Java. But there are more complex requirements. Those are like the one we are talking, like storing number. That's just storing one number in a variable, because variable, those primitive type, can hold only one value. But if you have 100 values, how do you store them? You don't want to declare 100 variables. Like you have, let's say, student roll numbers you want to store, or student IDs you want to store, and you have hundreds of students, so you don't want to declare 100 variables of int type. And you know that you can use like arrays for those kind of stuff, because array is used to store same kind of data. Same kind of mean is they all integers, or it's all strings, or all characters, those kind of stuff. So as long as the data is same type, you can always use arrays. And the arrays are already kind of available as part of the language itself, so that you don't have to really do anything. The only disadvantage with the arrays is that you have to define their size in advance. So let's say you declare an array of size 100, so you can only store 100 values in that array. What happens if you have more than 100? Well, then you have to increase the size of array. So it means you have to make the code changes and those kind of stuff. So for that, to keep that in mind, so there is another thing. I know we have discussed this in previous videos, the linked list, actually. So the linked list is also another data structure. Just forgot to mention that in the arrays, all the elements or the data is stored in contiguous locations in the memory. So basically, they're just from 1 to 100, they're all sitting next to each other. So they're not really stored in different places in the memory. So that's one of another reason, is because if you want to declare an array of like a size 100, it's important that you have 100 memory locations available together in one place. So that's one of the disadvantage of arrays. So you need to really know the size of the arrays beforehand. But in as an alternate to the arrays, there's another thing called linked list. So we're going to discuss today about the linked list actually. So if you want to think of the linked list, and linked list is also like very similar like arrays, but it's a growing um, data structure. So it means it's not restricted by the size. You don't have to really declare the size of linked list. You can keep adding elements to the linked list actually, and those those elements in the linked list doesn't have to be stored in contiguous locations in the memory. So this means if you store one element at one particular location, other element could be stored anywhere in the memory, so it doesn't have to be contiguous. So if you have read about linked list, so the conceptually or the pictorial version or how the picture looks like, it looks like very like this actually. But before you go there, so let's go to this part here. Board in the linked list there's a concept of a node actually. So node is the placeholder in memory where your data is stored. This is a node actually. And but if you see, the node has two parts. I draw a line here, and the first part is where you store your data. This could be integers like a student id, it would store in the data. But there's a second part to this node here. It's a pointer to the next node. So this pointer to the next node is really the memory address of the next location where the next element is stored. That's what it is. So if we come down to here, I have this node 1 here. It has value of 1, but you see the next one, this second part is stored the memory address of the next node. So below I have put memory address. This node is stored at 1000 location, this is stored at 1001, this is stored at 1002. But remember, I just make them sequentially, but they don't have to be in sequence because this can be anywhere in the memory. So I just keep it simple, just made sequentially. But this could be really, this is 1000, this could be 1200, or this could be like 1500 somewhere. But just to keep things simple, I just make it like this one. So this is a first node and is stored at location 1000, and the second part of this node, that where this second element is. So I said 1001 location, and this is 1001 location. That's why I showed a pointer here, and the number 2 is stored here. Then the second part of this node, so it is 1002, which is this one, and number 3 is stored. But if you see number 3, we don't have any pointer, so it means it's the last element. So basically we put a null, and that's kind of the marker to tell this is the last node of this linked list actually. So the important thing to know about the linked list is there's always a pointer to a head, because you are storing something in the memory. You need to keep some kind of reference to that one, so that you don't lose it, otherwise you don't know where it starts. So that's why you always have access to the head of the linked list actually. So if you want to see the advantage, like is keep growing, you can keep adding elements, and it's only limited by the amount of memory is available in your system. But if you want to add any element of this, if you want to add a new element to this list, what you have to do is, because you are always at the head, so you have to always keep going, scanning these elements, this element, and then you have to add it. So basically you have to always do sequential traversal of this list and then go to the last element and add it here actually. There are ways to add elements in between, but just for simplicity we're just going to focus adding elements at the end actually of this list. So now we are going to do the program part of this thing. So let's see, how do you represent this thing in or how can you implement this linked list yourself in the memory actually. Okay, so simple. So I think let's try to keep things simple. So first thing, you need to represent this node actually. And if you see this node, what this node is made of actually, this is made of data. This is one part, and this data could be anything. It could be int, string, float, or even some kind of class. you could have a student class as part of this data, so it could be more complex things, so it doesn't matter. There's another part which is a pointer to the next node. So it means pointer to the next node is really a node again, actually, if you think, so there are two parts of this one. So let's try to do some programming and then we can go back and forth. So I just created a package here. I'm going to create a new class called node. So I'm just going to keep one class here just called node actually. And as I mentioned, the node has, so there are two parts. So I'm going to create one part called data, but this could be more complex, but for simplicity we're just going to keep it as data. Another thing we said is that okay, so let's make a constructor quickly for this one. So we say public node. Yeah, people can just create a node, they can just send the value. So let's say this dot data equal to data. So this is one part of the whole thing, so far we just represented this part, but we also have to represent this part as a part of the node actually. So what this really means is we're going to create, this is really of type node, so it's really referring to itself. You want to say we call it just next. So that's the representative. So this whole class, if you see, this just mimics this node here, very simple, but this is just a standalone node actually. We don't have the linked list yet, so I'll just keep it here in a separate class. So what I'm going to do is I'm going to create another class called, let's say I want to call it my linked list. That's what I'm going to call this class, my linked list actually. So, and if you notice, my linked list, that class will represent the real linked list actually. And if you notice, this is the list I'm going to represent using this my class. So one of the important thing on my linked list is I said we should always have a reference to this linked list where it's stored in the memory, and that reference is really the head of the linked list actually. So what I'm going to do is in this thing, so I'm going to declare a node and its main head, which is of type node, and a constructor. Let's say it will be just just constructor, and actually that's it. This is a linked list actually. It has a reference to the head, and that's it. But this is not useful actually. Why? Because we need to have the ability to add elements into the linked list actually, otherwise it's of no use. So what we are going to do is let's say we are going to create some method which will, so this method will return this my same linked list, and I'm going to say add item and add item. So where I want to add the item, I want to add the item to this linked list, this one. This is, so think of this is just a small data structure which is for linked list now actually. So I'm going to add elements to this one list, so I'm going to pass this, so I'm going to call it just list, and what I want to add, I want to add this data here. Okay, so what is it? Oh, it wants me to some return, so I will do that in a second. So if you see add item to this list, I want to add this data. So it means before I do anything, I need to create a node actually, because I have the data. So if I do like this, new data, and I can pass this one, not new data actually, say new node, and I can pass the data actually. So you see this one, whatever the node I have this constructor, that's what I used. So here I make the node now. So okay, so it's complaining, so let me just return the list, because I think the same list we are going to return back. So we're going to add some elements to this and return this back. So okay, so we have the node here. Okay, now how do I add? So first you have to create the node. So now I create the node. Now I need to add this node to the linked list actually. So how can I add it? So I'm going to, so this is a linked list, so I'm going to check if this linked list is empty right now. So how do I check empty? So I can say if list dot head. Okay, if it's null actually, so it means this is the very first element I'm inserting here. Let me also put the else part here. So it means this, so the list is empty right now. If that's the case, if the list is empty, then what I'm going to do, I'm going to take this head and I'm going to assign this node to it. So it means this node goes as a head, or that becomes the head of the linked list. Simple. But if this is not empty list, then what we have to do is we have to if you remember, what I did. If this is not empty list, then I have to go traverse this list, whole list, and I have to keep going and find the last element. Once I find the last element, then what I have to do, remember I have the node, so this last element and the dot next, which is this null, I have to assign that node whatever I created, and the next of that node I have to set to null, so that it becomes like fourth element really. So let's see here. So what I'm going to do is now, so we have to traverse the list. So let's say we have this list dot head, and we have to assign it. I can assign to, I'm just trying to get a, this is last. I'm just trying to get a, I'm getting a pointer to the, so I don't want to disturb the head actually. So what I'm doing, I'm taking the head and putting this into a new variable, node variable. So now what I can do is I have to keep checking until I hit the last dot next is null. So I'm saying last dot next not equal to null. If it's not equal to null, then what I have to do is last will become last dot next actually. And that's it. And so when I come out of this loop, this last will really contain the last element of the list, in which in this case is this one actually. So my pointer will be at this one. So what I did, I start a loop. I said while in this node dot next is always this part, the address part here, pointer to the next, is not equal to null, go here. When it goes here, because dot next is equal to null, so it returns this third node now. So we are really, so this last is really containing the third node now. So what I'm saying is now this third node dot next will become my node. So whatever the node I created earlier, so I'm going to assign that node to this third, and that's it. Because I'm assigning to this one, but this node's next is already null actually, because if you go here, this is always null because we didn't really initialize or nothing, so it is by default it goes to null, so we don't have to really set it to null. I mean, I think you could have done like something like this equal to null, but I don't think you need to do, because we never initialize it, so just keep it simple, and then you return the list actually, as simple as that actually. So now we have the linked list, but I think what we want to do is we want to have the capability to, let me just make it a little smaller. Let's say we want to print the list so that we know that there's a linked list already. So what I can do is I want to write a method here called something like print list. This is, I'm going to pass say my linked list here, again list. We have to print it now. So I'm going to get a reference to the head. So node, I can say current node equal to this. So I don't want to disturb the head, that's why I'm making copy of this head. So this is my really head now. So if I'm saying if current node not equal to null, so I mean current node not equal to null, so it means this node still has some kind of value. So I think what we can do is print current node dot data, and we can put little spacing here so that it doesn't overlap each other. And we can do here, now we have to increment the current node to the next one. next, and that's it actually. So if you think, if you see, we have this method to add elements to the list, we have that method to print the list, and this is our linked list structure. So these are just helper methods, that but the structure is just this much. What we are doing, mm, we're just adding elements, but the only thing we are really keeping is head, that's all. There's not really data stored in this list here itself, so we're just keeping track of the head. So let's use it. So I'm going to create a class and with the main method, so we can just let's call it main actually. Okay, so this is a class main. So what I'm going to do is, so what we have to do, the only thing we have to do is we have to create a my linked list. That's our my linked list, so I can just my list equal to new my linked list. Okay, that's it. So, and what we can do is my list, we can add some stuff. So it says you have to pass the list, so my list, and I'm going to pass, let's say, 1, and I'm going to add another element, let's say, so I add 4, I add 6. Now I want to print them. Print this my list, this one. Okay, and maybe I want to add few more elements after that and print again. Let's see what happens. I just added 10 and print. Okay, so I'm going to run it now. Okay, so you see it printed 1, 4, 6. Okay, then it printed the list again actually. So I should have put little I'm just trying to put a new line so that I think they are showing all on the same one actually. So I'm just trying to, yeah, so this came from the first list because we added 1, 4, 6, then we printed it. After that, put a new line, and then we added 10 actually. So it means now next list should have 1, 4, 6, 10. So I hope you understand this concept, how you can implement the list yourself. In subsequent chapter, in the videos, we're going to discuss about how to delete an element, those kind of stuff actually, and we'll go further uh, other data structures too. So this concept is simple. You have to understand this is a data and this is a node. It has two parts. First is the data, other part is just the pointer to the next node. So this is really a node actually. So it's a self reference to the same node actually. And we need to just keep track of the head. It's 1,000 location and next location 1001, and this is, so that's the way it keeps track of all the elements where they're stored actually. So I hope you like this video. Please consider subscribing to the channel and like the video. Thank you. Bye.